Here we have a VCU, viscous coupling, prop shaft slippy thing that always goes wrong off a Freelander 1. This is off a 2 litre L series diesel. I believe it's the same unit for the TD4 L series diesel and K series petrol. V6 is different. Basically, what does this do then? So the front axle and rear axle on the Freelander are geared slightly different. This provides some form of slippage to correct that. Then also, if you're off-roading, your front wheels start to slip. This spins quick, locks this up, puts drive to the rear. Now these things go wrong. Basically it's a series of plates with holes inside of this and a silicon-based fluid. The fluid goes hard over time, it degrades, causing this to not slip correctly. So this is basically all one drive, no slippage. Which puts strain on the transfer box and the rear axle and will eventually lead to failure. Symptoms for this is on hard lock you'll feel a rumbling from the rear diff, or when manoeuvring at slow speeds, for example parallel parking, it feels a bit like your brakes are sticking on. If you're experiencing any of those symptoms, whip the prop shaft off, see if it goes away. If it does, then you need this refurbing. Best way to take this off, wouldn't bother in situ, take the whole prop shaft off the car. It's only a few extra bolts, takes minutes. These prop shafts can get quite tight onto this viscous coupling, and it's much easier to separate it when it's off the vehicle. So what you need to do is, if you look in here, you have a bolt and a big washer. The bolt can stay in, you just got to loosen it off enough to get this horseshoe washer out. Best way to do that once you've got it off is, once you've got the washer out, just drive a large chisel where my finger is and it'll pull the prop shaft off. They're very tight to get off otherwise, and you don't want to go beating these around with a hammer or this with a hammer. Right, so this one's knackered, so I've taken the prop shaft off the car. I've picked up another second-hand one for pennies, which is also knackered. Thought I'd have a go at refurbishing it myself. You can send them off to numerous companies that do the refurbs. Prices range from about 280 quid to about 350, depending on who you use. So, if you follow me into the shed, we're not at the workshop today because it's easier for me just to come out and tinker with this in the shed at home. You have to excuse the mess. It's biodiesel refinery, laundry room, general storage room, so yeah, it's a bit of a mess. Anyhow, so what we've done with this unit here is we've drilled a hole either side. We've drilled an M8 here and an M10 down there. We've threaded them so that we can plug them up afterwards. Reason one side's M8 and one side's M10 is because I blunted my M10 drill bit. It's about 8 to 10 mil thick, these end sections, so you're going to need a decent drill bit, slow speed on the drill with some cutting oil as well, ideally. Anyway, so we did that on this unit. Literally no fluid came out. It's so thick and goopy and horrible. So what I've been doing is putting this fitting in to the M10 side, bit of tube, filling the unit up with either silicone spray or a bit of WD-40, leaving it to soak overnight, clamping one end in the vise of a spanner, as you can see, and having a bar on the other side, turning it round to mix it all up. Then we've also threaded a Schrader valve to M10, winding that into the M10 fitting, putting the air compressor on it at about 50 psi and just leaving it. And we got quite a bit of shit out of it, as you can see. Unmixed, it's like the texture of tiger seal. If you've ever done car body work, it's that sort of texture. So you can see why it doesn't function and why you can't get the bloody stuff out. So anyway, we've managed to get a fair bit out over the course of about a week. So we can now turn it with relative ease with a bar. So what we're going to do now is, we've got an M10 grease nipple fitting. We're going to put that in the M10 hole. Leave the M8 hole open so the air can escape. And I'm going to gradually fill it with replacement silicone fluid. I've gone for 30,000 CST, which is slightly thinner than what would have been in it from factory, but as I've definitely not got all of the thick goopy stuff out, I've gone for slightly thinner because it'll all mix up inside. So the test we want to do, we want to fill with a grease gun, silicone fluid, and then we want to get the bar in a 1 o'clock position, put 7 kilos of weight on it, and then wait for it to fall to about the 5 o'clock position. And I want that to happen in about 15 to 20 seconds with 7 kilos of weight on the end of the bar at a length of about 80 centimeters. As you can see, it's a bit Heath Robinson. That mark is 80 centimeters. So we're going to go put 6 kilos of weight on the end because there's probably about a kilo in the bar. Then basically we're going to fill it with silicone fluid until we get to the right speed and drop. Then we're going to plug the holes up. What we're going to do, we'll cut down a couple of bolts, put some washers on so either side are about the same weight to keep the balance right. Stick some PTFE tape around them. The fluid's so thick it's not going to leak anyway, but we'll put a bit of PTFE around there to be safe. Got a new bearing to go on that end. This bearing's alright. I'm not just going to change it for the sake of it. It's a waste of money and I'm tight, hence why I'm refurbishing this myself. We'll chuck it back on the Freelander and see how it performs. So I hope that's given you a little rundown on the VCU, how it works, how you can refurb it. Quite handy. 24mm multi-sided socket goes on the end, as obviously a 24mm ring end spanner makes it easy to test. So yeah, wish me luck.